Today, let me take you thousands of years back to Greece. There was a child called Pythagoras who was extremely interested in mathematics and particularly numbers. He reads a book one day wherein he learns about Babylonians and their special 12-knot circular rope. So this 12-knotted rope had 12 knots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These 12 knots were at equal distances. And if you stretch 4 on the ground, 1, 2, 3, 4, 3 along the wall, 1, 2 and 3. So you get a right triangle with hypotenuse 5. 1, 2, 3, 4 and 5. So this triangle with sides 3, 4 and 5 was called a special triangle. Well, why special? Because if you make a triangle with these 3 sides, it would always turn out to be a right triangle. Now Pythagoras got really fascinated and he wanted to know more. So he further reads how Greeks used this to find whether the pillars of temples or monuments were straight, that is perpendicular to the ground or not. Pythagoras got excited. He wanted to make a triangle for himself now. So he takes out a chart paper and cuts out a triangle with sides 3, 4 and 5. So he got one right triangle. He makes more such triangles till he can make no more. So he got exactly 4 same right triangles and he decided to arrange them now. He tried a lot of different patterns. He keeps trying different patterns till he gets an idea. He arranges them like this and got a nice pattern. After measuring these sides, he found that the empty space was actually a square with side 5, area 5 square. Now this was really interesting. He changed this arrangement a bit and found another nice pattern. Well, after measuring the sides, he found that this was a square with area 4 square, whereas this empty space was a square with side 3, area 3 square. Now this made Pythagoras jump with joy and excitement. Why did Pythagoras jump with joy and excitement? What actually made him this happy? Let us see. So these were the 2 nice patterns that he had found. So let us try to understand what he concluded from these 2 patterns. So he arranged both of these patterns on the same table. So area of the table should be the same. In this table, we have 4 triangles plus some empty space. Here also we have 4 triangles, 1, 2, 3, 4 and some empty space. So we know that area of 4 triangles plus some empty space should be equal to area of 4 triangles plus some empty space. Now the 4 triangles are the same on both the sides. So I can say that area of empty space here should be equal to area of empty space here. Now what is the area of empty space here? In the first one I have a square, empty space is a square with side 5, so area would be 5 square. What about here? Here I have 2 empty spaces, as in this empty space are squares, 2 squares. One is of side 4, area 4 square. The other empty space is also a square, which is of side 3, hence area would be 3 square. So since the area should be the same on both sides, 5 square should be equal to 4 square plus 3 square. Now Pythagoras tried this with a lot of different right triangles and he gave a theorem that stated that in a right triangle, c square should be equal to a square plus b square. Now let us see what is this a, b and c. So if this is a right triangle with sides a, b and c, then c is actually the hypotenuse, the side opposite to the right triangle. A and b are the perpendicular sides. So his theorem said that the hypotenuse square would be equal to the sum of squares of the other 2 sides, or you can say the perpendicular sides. So this is what the Pythagoras theorem was, and this is precisely what made him that happy. Well, Pythagoras theorem is unique in such a way that you can prove this theorem by many different ways. We have just seen one of the ways in which he proved it. But there's a book called Pythagorean Proposition that contains as many as 367 different proofs. So what is more interesting is that the converse of this theorem also holds. So we know that in a right triangle, if I have three sides ABC, then a square plus b square will be c square, where c is the hypotenuse. Then the converse says that if there are three numbers a, b, c, such that a square plus b square is c square, then I can say that that would give me a right triangle. Well, this is what is a Pythagorean triple. Pythagorean triple consists of three natural numbers a, b and c, such that a square plus b square would be c square. We've already seen, we visually saw it, that 3 square plus 4 square is 5 square. Mathematically also you can see, left hand side would be 3 square is 9 plus 4 square is 16. So left hand side becomes 25. 9 plus 16. Right hand side is 5 square, which is equal to 25. So you see that the left hand side is 25, right hand side is 25. This holds. Hence I can say that 3, 4, 5 is a Pythagorean triple, where 3 is A, 4 is B, and 5 is C. Note that this C is the largest number, is the hypotenuse here. So would -3, -4, -5 also be a Pythagorean triple? It will be if -3 whole square plus -4 whole square will be equal to -5 whole square. Now let's try to see this, whether this holds. Left hand side is -3 whole square, 9, plus -4 whole square, 16. 9 plus 16, 25. Now let's see the right hand side. -5 whole square, which is 25. So left hand side equals right hand side. Hence this should be a Pythagorean triple. But no, it is not. Why is it that even after satisfying this condition, it is not a Pythagorean triple? Let's revise the definition again. It should consist of three natural numbers. So -3, -4, -5 are not natural numbers. Hence is not a Pythagorean triple. Now next what I do is, I multiply each 3, 4, 5 by 10. So I get 30, 40, 50. Now will this be a Pythagorean triple? It will be if 30 square plus 40 square equals 50 square. Let us see this. Left hand side here is 30 square, which is 900, plus 40 square, 1600. 900 plus 1600 gives me 2500. What about the right hand side now? Right hand side is 50 square, which is 2500. Now the left hand side is equal to the right hand side, and hence this holds. So I can say that 30, 40, 50 is a Pythagorean triple. In fact, I can generalize it by saying that if ABC is a Pythagorean triple, and I multiply each ABC with a positive number P, then PA, PB, PC would also give me a Pythagorean triple. Okay, so these are the Petronas twin towers, and they are in Kuala Lumpur, Malaysia. You know what? From 1998 to 2004, they were the tallest building in the world. Oh, right. You might be wondering, why am I suddenly talking about towers in a mathematics lecture? There is a famous quote that says, go down deep enough into anything and you will find mathematics. Let's try to find maths here. So you see that these two towers are actually connected by a sky bridge. And this sky bridge is supported by a beam on both these sides. So each support beam is actually forming a hypotenuse of a right triangle. And hence Pythagoras theorem was used to find the length of this beam that was required. So for ease, let us just take some random numbers to find the length of the beam that was needed. I say that the sky bridge was 16 meters and it was supported at the center. So this is 8 and 8. This beam was supported 15 meters vertically down. So this is 15 and 8. If you see that the beam is actually the hypotenuse of this right triangle, opposite to the right angle. Let's say that the length of this beam is L. Let's say that the length of the beam is L. So now I can use Pythagoras theorem to say that hypotenuse is L, L square would be equal to sum of squares of the other two sides, the perpendicular sides, which is 8 and 15. So this would be equal to 8 square plus 15 square. So L square would be equal to 8 square, which is 64, plus 15 square, which is 225. So L square turns out to be 225 plus 64, which is 289. Taking square roots, I get L equals to plus minus under root of 289. Now I can ignore the negative one because we need to find the length, and it cannot be negative, length has to be positive. So ignoring the negative, I get length would be equal to under root 289, which is 17. So the length of this beam becomes 17 meters, and that's how Pythagoras theorem was used to actually find the length of the beam that was needed. Let us look at another example. So say you locked out of your house and the only open window is on the first floor, which is 12 feet from the ground. So you need to borrow a ladder from one of your neighbors. Now, before actually going to ask for a ladder, you need to know the minimum length of this ladder. So how do you find that? Well, you know that the ladder can be placed only 5 feet from the house, since there are bushes along the house. So let's try to place this ladder. Now you would see that this ladder is actually forming a hypotenuse to this right triangle. Let's call the length of this ladder as L. So I can say that L square, which is the hypotenuse, square would be equal to sum of squares of the other two sides. Other two sides are 5 square plus 12 square. So L square becomes 25, 5 square plus 12 square, 144. L square is 25 plus 144, which is 169. And L is taking square root plus minus 169. Again, negative can be ignored. Length of the ladder has to be positive, will not be negative. So I can say that L is plus 169 under root 169, which is 13. So the ladder would be 13 feet in length. So we've seen how actually Pythagoras came about his theorem. We've seen the applications of this theorem too. Now try to find some right triangles and try applying Pythagoras theorem.